Hello, my name's Alistair Parks, and in this video we'll be looking at ICFD setup and post-processing in the Oasis Elastana environment. To help you get to grips with Elastana's incompressible computational fluid dynamics, or ICFD solver, Primer comes with an ICFD setup tool. From Primer 19.0, the tool lets you specify an output directory for the keyword file. A JSON file is now also written, containing inputs required for post-processing in Reporter. Reporter now comes with an ICFD assessment library template, which can be found in the new ICFD tab. Designed to be used with the setup tool in Primer, the template includes an animated contour plot of fluid velocity magnitudes on a cut section through the model, and a graph of viscous and pressure drag forces. Let me show you how it works. So we're in Primer and I have a simple test model here. It's just a cuboid volume. If I make the central part a bit more transparent, we can see that inside we have a sphere as our test piece. So the first thing I'm going to do is select the ICFD setup tool from the tools menu. And this has a whole load of steps that help you set up a simple ICFD model to get to grips with the solver in Elastana. The first thing I'm going to do here is increase the number of boundaries from 3 to 4, and that gives us a new row in the table here. And we're going to need to define which parts form our inlet and outlet, as well as any of the other boundaries in the fluid volume. So to select the inlet, I'll pick the part on the left-hand end here and set the fluid velocities. And then for the outlet, I want to pick the part on the other end of the volume, and this here will give it a pressure. And then for the test piece itself, I want to select part number 1, and for the slip wall along the sides, that's part number 4. Now for the test piece itself, let's get the force output. We'll set 6 boundary layers for that and 2 boundary layers for the slip wall. We can check for holes to make sure that our geometry is complete, so that's all good. And I'll just leave the default settings for density and viscosity and so on. So the new part for Primer 19 is being able to select an output directory for the keyword and JSON files. So if I just set a directory here, then it's pretty much ready to go. The final thing is that it's already identified that the center of our model is at y equals 0, and that will be used to take a cut section during the post-processing in Reporter that you'll see in just a moment. So now that everything's ready, I can click Generate to generate the ICFD model. This is showing all of the ICFD keywords that have been created. And if we look in the output directory, you can see we've got the keyword file that's been produced and also the JSON file, which contains that setup data that's used by the Reporter template. So once we've run the model in Elastana, we should end up with a set of results files that look something like this. I've also created a Reporter output folder, which we can use to put any of the images and other outputs from the new ICFD Reporter template. So we can try that now. So in Reporter, we can go to the new ICFD tab and select the ICFD assessment template. When the template opens, it prompts you to select the Elastana keyword file of the job that you want to process. So we'll select the ICFD model, and then to select the JSON file created by the ICFD setup tool in Primer. So we'll select that, and then select the directory containing the analysis results. That's this very directory here. And finally, a directory to write images or curves to. So we'll select the folder that I created earlier. Once we've done that, Reporter will run through, first of all opening up D3plot to capture the cut section of fluid velocity magnitudes. And then once that's finished, it will open THIS to calculate the drag forces. And that's the template generated. So once it's generated in Reporter, we can play the animation, of the fluid velocity magnitudes, and on the right hand side we have the sum of viscous and pressure drags, and they're shown in their x, y, and z components. And finally, as a bonus, on the second page of the template, there's a summary of all of the input parameters that we set in the primer setup tool. You can save this template out to PowerPoint or PDF, and hopefully it's a useful way of you exploring the ICFD features of LS Dyna. Do contact us if you have any questions. Thanks for watching.